Hey guys, welcome to Algebra 1. Today's lesson is going to focus on dividing polynomials. Now all that you know about factoring and the laws of exponents are going to get you through this lesson. You ready? Let's go. All right, so let me jog your memory first so you remember how to simplify something like this, okay? So if we apply what we know about the laws of exponents, to simplify 20x to the fifth over 4x squared. Make sure I got my pen here so I can write. Okay. So to handle this one, if you remember, the first thing that we would do is handle the coefficients. So we'd go ahead and divide 20 divided by 4. And we'd say, all right, well, that's 5. And then x to the fifth divided by x squared. The laws of exponents tell us that when we have a situation like this, a quotient of powers, we subtract the exponents. So 5 minus 2, that's 3. So I know the other part of this is x to the third, okay? Do you remember we did that earlier in the course? That's going to help us learn how to divide polynomials. Okay, look at this one. All right, deep breath, because that's a long one. We've got 35y to the fourth plus 20y squared minus 18y, that whole quantity. We're going to divide it by 5y. Okay, it looks a little intense, but it really breaks down to something really simple. All we're going to do is take each of these terms and divide it by 5y, okay? I'm going to rewrite this a little differently because I think it might make you a little more comfortable if you saw it like this. 35y to the fourth divided by 5y plus 20y squared divided by 5y minus 18y divided by 5y. That's basically all that we're going to do here. Essentially, you are taking that 5y and dividing each term by it. And whatever our answer is our answer to the problem, okay? So I need to get us a little more room to work up here. Let's get rid of some stuff. Let's get rid of example 1. Let's cut that out of the picture. And let's move this up. And then let's move this up a bit so we can get a little more space up here. Okay, now let's get our pen back, and we're ready to rock. Here we go. Okay, so if we look at this first chunk right here, this first bit, let's handle the coefficients first, just like you already know. You're going to completely ignore the rest of this problem and just focus your attention on that first bit. So 35 divided by 5, I know that's 7. All right, now y to the fourth divided by y. We remember there's an invisible 1 we don't see, right? So to handle y to the fourth divided by y to the first, just subtract your exponents. So that'd be y to the third. Okay? So that first part just simplifies to 7y to the third. Let's look at the second part. So we have its plus, so go ahead and put that in there. We have 20y squared divided by 5y to the first. Go ahead and get that in there. Okay, so what do you think we're going to do first? Right, handle those coefficients. So 20 divided by 5, that's 4. Y squared divided by y to the first, just subtract the exponents. 2 minus 1, that's just 1. So this is y to the first, but when it's a 1, we don't typically write the exponent. So 4y for the second one. Let's look at the last one. All right, we have 18 divided by 5. That might have made you a little uncomfortable because you know it's not going to divide evenly, but we're not afraid of fractions in Algebra 1. Not a big deal. I can't simplify this to anything simpler than 18 divided by 5, so I'm just going to leave it as 18 over 5. Just leave it like a fraction. No big deal. Okay? Then I've got y to the first, right, divided by y to the first. So 1 minus 1, that's 0. And then think back a bit. I'm going to come off to the side. Remember, anything to the 0 power is 1, right? So essentially, I'm going to be multiplying 18 divided by 5 times 1. But that doesn't change anything. So just leave it as it is. Just leave 18 divided by 5. And you've got it. This polynomial is your answer. So when you divide what we started with, that long bit divided by 5y, that's what you get. And that's your answer for that one. Okay? Let's try another one. Okay, find the quotient. So we have 18x to the 6th plus 27x to the 5th minus 45x cubed, all divided by 9x squared. Okay, so this problem is set up a little differently, but you are doing the exact same thing. You're going to find the quotient. Okay, so I'm going to break this up into chunks like we did a second ago. In math, if you can chunk things up and kind of look at them in bits, a lot of times it's easier to process the problem that way. So don't feel like you can't manipulate this the way you need to get through it. Because as long as you're following the rules for math, you can basically do whatever you want. Okay? So I'm going to get that out of our way. I'm going to move that up a little bit, get us some room here. Okay, so I'm going to chunk this problem up so it's easier for me to process. So I'm going to write it as 18x to the 6th divided by 9x squared. Okay, then I have plus 27x to the 5th divided by 9x squared. Okay, then I have minus 45x to the 3rd divided by 9x squared. Okay, so I've got that all broken up. Now I'm just going to handle each piece separately and get through this problem. So if I look at the first bit, look at the coefficients first, right? So you have 18 divided by 9, that's 2. I bet your mental math is getting so good now that you've been working with these numbers. Okay, now look at that second part, the variable part. I have x to the 6th divided by x squared. So what do we do there? Right, subtract the exponents. So 6 minus 2, that's 4. So 2x to the 4th. All right, so I'm done with that first part. I'll go ahead and just cross it out because I'm done with it. Let's look at the middle bit. Look at our coefficients. I'm going to go ahead and bring the plus sign down. 27 divided by 9, that's 3. And then as far as our exponents go, what are we going to do? Subtract. So 5 minus 2, that's 3. So this part's going to be x cubed. Okay? Let's look at the last part. I went ahead and brought my minus down. So 45 divided by 9, that's 5. Okay? And handling my exponents over here, I know I need to subtract. 3 minus 2, that's 1. And when it's an exponent of 1, we typically don't write it. So that crazy looking problem that started out just simplifies down to this. 2x to the 4th plus 3x cubed minus 5x. And we're all done. Okay? Let's look at the next one. All right. So this one's a little different because we've got 2 different variables in this problem, but the process is still the same, okay? If you remember back a while, I told you that you'll never run into exactly the same type of problem every time. So don't try to memorize exactly the steps that I'm taking, but memorize the process because it's the same process I'm taking every time, okay? So what I do up here, so we have room to work, is I get rid of some stuff first. All right, I'm going to slide that up. And then if you remember, the first thing I keep doing every time is chunking it out. Just break it up into chunks, okay? This one's kind of short, so I'm not going to have but 2 chunks here. All right, so I'll have 28 to the 6th, b to the 4th, divided by 4a cubed b. All right, got the first bit. Then I have minus 16a to the 4th, b squared, over 4a cubed b. Okay, got it into chunks. So now I'm going to simplify what I've got here. Same thing, handle your coefficients first. So you have 20 divided by 4, mental math, that's 5. Or if you don't want to do mental math, pull out a calculator. There's nothing wrong with that. Okay, if I handle the a's, I have 6 and 3, so I know I need to subtract those. 6 minus 3 is 3. So a to the 3rd. Then I have a b, so I know it's an invisible 1, right? Subtract these. So 4 minus 1, that's also 3. So b cubed. So that first part just simplified right down to 5a cubed b cubed. And you've handled that, you're done with that part. Okay, I'm going to bring down the minus sign, then we're going to handle this part. So coefficients first. 16 divided by 4, that is 4. All right. Let's handle these exponents with the a's. We've got a 4 and a 3. I need to subtract. 4 minus 3, that's 1. So a to the first, but remember we don't generally write the 1. All right, now if I handle my b's, there's an invisible 1 just to help me subtract. So 2 minus 1, that is 1. So then I've got just b. Okay? And there you go for that one. That quotient just simplified to 5a cubed b cubed minus 4ab. All right? Let's keep going. What do you know? It is your turn. So go ahead and press pause, take a few minutes, and work your way through these problems. And when you're ready to compare answers with me, go ahead and press play. All right, let's see how you did. Get my little pointer tool, I can move these out of the way. So for the first one, your answer should have been 4x to the 4th minus 7x cubed plus 3x. And for the second one, 3x cubed y plus 5x squared. Now, if you want to see how I got those, stay with me, and I'll show you. Okay. So I followed the same process we've been doing. I started out by rewriting this into my chunks, into those 3 chunks in this case. So at first, I think I'm going to need a little more room at first. Let me get that out of the way. Then let's move that up. All right, here we go. Get my chunks going. 28x to the 7th divided by 7x cubed minus 49x cubed, x to the 6th divided by 7x cubed plus 21x to the 4th divided by 7x cubed. Okay? So I've got it in my chunks. Now I'm just going to simplify. If I handle my coefficients first, 28 divided by 7, that's 4. Subtract my exponents here. So 7 minus 4, that's 4. 7 minus 3, that's 4. All right. Minus 49 divided by 7, that's 7. Subtract my exponents, and I get 3. All right, got that chunk. Last bit, got my plus sign. 21 divided by 7 is 3. Subtract my exponents, and I get 1. And remember, we don't typically write the exponent when it's 1. And there we go. That is how I got the first one. Now, if you want to see the second one, here we go. Same process. Break it up into chunks. Let's move some things out of the way here. All right. Let me get my chunks. So I have 30x to the 5th y cubed. I'm going to divide that by 10x squared y squared. So I've got the first bit plus 50x to the 4th y squared divided by 10x squared y squared. All right, now let's just break it down. 30 divided by 10 is 3. Subtract my exponents with my x's, and I'd get x to the 3rd. Subtract my exponents with my y's, and I'd get y to the 1st, which remember we don't generally write. So I've handled that. Plus 50 divided by 10, that's 5. Subtract the exponents. So 4 minus 2, that's 2. So x squared. 2 minus 2, that's 0. Remember, anything to the 0 power is 1. So essentially, it would be 5x squared times 1, which doesn't change anything. So just disregard it. That's how we got the second one. 3x cubed y plus 5x squared. All right. There's a little more to this. All right, there's also a bit of this where you have to know how to factor in order to find how to divide some polynomials. So to jog your memory with that, let me bring you back to fractions. Now, remember when we simplify fractions, basically what we're doing is finding the greatest common factor and canceling it out. So, for example, 12 divided by 15. I want to find factors of 12 and 15, and I want them to be there to be a greatest common factor between them. So if I think about 12 and think about 15 and think about the factors, the pair that's going to work for me here, I know 4 times 3 is 12. And I know that 5 times 3 is 15. So 3 is the greatest common factor here. You can cancel out those 3's, which would just leave you with 4 over 5. So you'd say, all right, 12/15 just simplifies to 4/5, because you factored the 12, you factored the 15, and then you just canceled out the greatest common factor. Okay? Keep that process in mind, because we're going to do the exact same thing but with polynomials, okay? So we're going to factor that numerator. Our denominator already has just one factor, and we're going to be able to cancel the things out to get through this one, all right? So think about what you remember about factoring, because we need to factor x squared minus 2x minus 3. So I'm going to come down. Let's go over here and do a little scratch work first. I'm trying to factor this. So if you remember when we were factoring, you're looking for a pair of factors. First of all, you want to factor the 3. And then you want to find the pair that the sum is -2. Okay? So let's factor 3. Because I'm ignoring the sign to start with. So I know 1 times 3. 3 is prime, so that's a short list. 1 times 3 will give me 3. Now go back and consider your signs. You really need a -3. And then you need to be able to combine these to get a -2. Now, when I'm multiplying, if my answer is negative, that means I multiplied a negative number times a positive number. So I need to figure out which one of these is going to be negative, so that when I combine them, I also get -2. So what if the 1 was negative? Let's just try it. If the 1 was negative, -1 times 3 would give me -3, but -1 plus 3 is going to give me +2. And I need -2. So that's telling me, okay, the 1's not what's negative here. It's going to have to be the 3 that's negative. Because, all right, 1 times -3 will give you -3. And 1 plus -3 is -2. So that means that this trinomial will factor to x plus 1, x minus 3. Okay? So now what I'm going to do is I'm going to go back to my problem, and I'm going to rewrite that numerator by its factors instead. So I'm going to replace x squared minus 2x minus 3 with the factors, x plus 1, x minus 3. Okay, let's do a little moving around here, get some space. Okay, so I'm going to replace that numerator with x plus 1, x minus 3. I'm going to get that scratch work out of our way so things don't get too cluttered up here. Okay. So I've replaced the numerator and I've written it by its factors instead. And my denominator is still my denominator, still x minus 3. Okay, so now kind of step back a bit and look at it. Do you notice a factor in your numerator that's also in your denominator? The x minus 3. So just like with the fractions where we just crossed out those common factors, we're going to just cross out those common factors. And so the answer is just this factor I'm left with, this x plus 1. And you're all done. That's what it was here. So with these kind of problems, the part that's going to probably take you a little bit of work is just factoring the numerator. And after you factor your numerator, it's kind of smooth sailing from there. You just cross out the common factors. Let's try the next one. Okay. So our numerator, trying to find a quotient here. We've got x squared plus 7x plus 10. And we're going to divide it by x plus 5. So if you remember what I did, start out by factoring the numerator. I'm going to scoot that out of our way a bit. I'm going to come off to the side, do a little scratch work. So x squared plus 7x plus 10. From what I know about factoring, I know I need to factor 10. So for 10, I know 1 times 10 will give me 10. 2 times 5 will give me 10. Okay. So now I'll look back at the trinomial and I consider the signs here. I need a positive 10 for my product. So that means I'm either multiplying two positive numbers together or two negative numbers together. Okay? And then looking back at my trinomial, I know I need a sum of positive 7. So there's no way that I could add negative numbers together and get something positive. So that means that my factors here are going to be positive. Okay? So let's look back and let's test it out. I need to find out which one of these pairs, when I add them up, is going to give me 7, positive 7. Well, I know 1 plus 10 is 11, so it's not that pair. 2 plus 5 is definitely 7. So I know this is the pair that's going to work for my factors. So now I'm going to go back to the problem, and I'm going to rewrite that x squared plus 7x plus 10 by its factors, x plus 2 and x plus 5. I'm going to write it here so you get an idea of what I mean first before I move over there. I'm going to replace that trinomial with its factors, and that's going to help me simplify this quotient. Alrighty, and I do need to erase. I'm going to run into that up here. Okay, now I'll leave that trinomial, or leave those factors up and copy those. So I'm going to write x plus 2, x plus 5, and then for my denominator, I still just have that x plus 5. Okay? So I have handled the numerator. I've got the denominator. I'm going to get this out of our way here. So if you remember what we did in the last problem, this is the point where you're at to see what you can cancel out, what's common to the numerator and the denominator. And in this case, it's x plus 5. So cancel those out, and you're left with x plus 2. And that is your answer for this one. All right, let's keep going. Let's try another. So I need to find the quotient of x squared minus 7x plus 12. So what do I do first? Right, factor the 12. I'll come off to the side. Okay, now I know 1 times 12 is 12. So is 2 times 6. And so is 3 times 4. And that's it. Now, if I consider my signs here, let me rewrite the trinomial so we can just look at that by itself first. Okay, so if I consider my signs here, I know I need to multiply and get positive 12. So that means I'm multiplying either two positive numbers together or two negative numbers together. But because in this problem, I know I need a sum of negative 7, then that's telling me it's the two negatives. That's going to be the case here. So just run down your list and then see which pair is going to work. Now, if these were both negative, negative 1 and negative 12, if I combine those, I get negative 13. So that's not the pair. Now, if I had negative 2 and negative 6, if I combine those, I get negative 8. So that's not the pair. If I had negative 3 and negative 4, I'd get negative 7. So that's the right pair for this one. So that means that this trinomial is going to factor to x minus 3, x minus 4. So going back to our problem, because we finished our side work over here, we're going to replace that numerator and write it by its factors. So we're going to write the x minus 3, the x minus 4 for the numerator. Let's scoot a few things around here, get some space. Kind of scooted that off a little too far, I think. There we go. All right, so x minus 3, x minus 4. All right, and that is typically right when things get crowded up here for me. So let me get rid of some things. All right. And then I'm going to go ahead and throw my denominator in there, that x minus 4. All right, so what do we do now? The fun part, you just start getting rid of stuff. Go ahead and cancel that out, and you're just left with x minus 3. And you're all done. All right, I think it's about to be your turn. Okay, so go ahead and take a few minutes, press pause, work your way through these problems, and when you're ready to check, press play. All right, you ready? Let's see how you did. Let's get the pointer tool up here. I can move these out of the way. So for number 1, the answer was x plus 9. That was your quotient for that one. And for number 2, x minus 3. Now, if you want to see my work for these, this is what I did. So the process we've been doing all along, right? Start out by factoring the numerator. So I need factors of 9 in this case. And I believe I do not have my pen. Get that. Okay. So I need factors of 9. So 1 times 9 is going to give me 9. And so is 3 times 3. So now I go back and I consider my signs. I really need negative 9. So that means one of the pair, or in each pair, one number is going to be negative. But I need to be able to combine those pairs and get a positive 8. So let's see. Is there any way you could combine 1 and 9 and get positive 8? If the 1 were negative. Because negative 1 plus 9 is positive 8. So that means that's the right pair of factors. So now if I'm over here back in my problem, I'm going to replace that trinomial and write it by its factors. X minus 1, x plus 9. And I'm going to get that scratch work out of the way so it doesn't confuse you. Now remember, you do not need to continue to erase your scratch work. I just do it so we can get a clear view of what's going on up here. Okay, so we've got the numerator factored. Let me write my denominator in here. X minus 1. Then you're at the fun part. Cancel out what's common. X minus 1, x minus 1. And that just left you with x plus 9. And that's how I got that first one. Okay. All right, let me show you how I got the second one. Did the same thing. Factor 24, because I'm going to ignore the signs to start with. Okay, so 24 has got a little bit longer of a list. I know 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And that completes the list for the factors of 24. So now we need to find the pair of factors that actually gives us negative 24. So that means out of these pairs, one of the numbers is negative. But when we combine, we get a positive 5. So let's run down the list and see. There's no way I could combine 1 and 24, regardless of which one was negative, and get a positive 5. There's just no way. Because if the 1 was negative and I combined it with 24, I'd get positive 23. And if the 24 was negative, I'd get negative 23. There's no way. Okay, 2 and 12, let's consider both cases. If the 2 were negative, it'd be a positive 10. And if the 12 were negative, it'd be a negative 10. So that's not the pair. Okay, I got a good feeling about this pair. Okay, if the 3 were negative and I combined it with a positive 8, I would get positive 5. I would get it. Negative 3 plus 8 is positive 5. So this is the pair that I want. So I'm going to replace that trinomial in my numerator and write it by its factors. So x minus 3 and x plus 8. And then I still have my denominator, x plus 8. Okay. I'm going to get my scratch work out of the way just so it doesn't get confusing up here. Okay. So now you're at the part where you start crossing stuff out. So that x plus 8, that's common. I can cancel that out. And I'm left with x minus 3. And you're all done. Okay? All right. I hope you're feeling good about how to divide polynomials, and you saw how you could use the laws of exponents in certain types of problems and factoring in other types of problems to get through how to divide polynomials. Hope to see you back here soon. Bye.